Stealth plays an important role in many modern games, and it's one way in which the audio can drive gameplay. In this video, we're going to look at one approach for an actor to hear or sense the sound made by another actor. Just off the side of the first cave in the demonstration project, that's bookmark key 6, there is a shy baby griffin. If we whistle gently, we can entice the griffin to come towards us. The system's controlled by this blueprint here, and for the moment we're going to put it into sound sensing mode and we're going to turn this fake distance option off. We'll be looking at that a bit more later. So as we enter this area, we get some text to screen telling us that we can call the baby griffin using the key E. And if we call it, it comes towards us. And then it'll pause for a while, it might go back. But if we continue to call it, it will come right up to the cave entrance. So let's take a look at this blueprint and see what's going on. As we enter the box collision here, the system looks at this enum for the entice method to see if we're using audio capture and sound sensing. We'll be looking at audio capture in a future video. So in this case we're using sound sensing, and what this does is it activates pawn sensing within another blueprint, which is the baby griffin blueprint. So we'll double click on that, and that opens up this, and we can see in this baby griffin blueprint we've got the mesh of the baby griffin itself, but the other thing we've got here is a pawn sensing component. And when we're entering that box collision, then this is what's getting activated. A pawn sensing component allows one actor to listen out for noise made by another actor. So now that the pawn sensing component is being activated, with its sensing updates being enabled, we'll receive events when it hears a noise, and then it triggers the movements of the griffin, which you can see here below. And going back to the controller blueprint, we can see that when we exit the box here, we call another function in that baby griffin blueprint, and that deactivates the pawn sensing by switching the sensing updates enabled to false. Let's have a closer look at this pawn sensing component. The green cone here is the peripheral vision angle, and this, the sight radius and the C pawns all relate to the visual seeing aspect of the pawn sensing component. Hearing noises is enabled, and the sensing interval governs how frequently it makes these checks. You need to set this to less than the hearing max sound age. For example, if the hearing max sound age, the age of the sounds we can hear, was set to 0.4 and the interval was set to 0.5, then conceivably we could miss a sound. It's worth noting that if the C pawns option is enabled and the pawns are visible, then these hear noises notifications are switched off, since we'll assume that if the pawns can see each other, then being alert to hearing each other becomes a bit redundant. And only sense players means that it will only sense player controlled pawns, so we can turn that on. You see here the enable sensing update is off by default, and that is what's being switched on and off here, so that the blueprint is not just ticking along performing all these checks when we don't actually need it to be. The LOS hearing threshold, or line of sight hearing threshold, is the max distance at which a full strength make noise event can be heard when unoccluded. In other words, when there's a line of sight between the pawn sensing component and the noise emitter that it's sensing. And the hearing threshold is the max distance at which a sound can be heard if there's no line of sight. So after the system has been switched on, it's now listening out for sounds, or to be more accurate, it's listening out for make noise events. So let's go back to the controlling blueprint, the baby griffin audio input. Now that the system's been switched on, we can interact with it using the key E. And what this does is it casts to the first person character to execute a custom event. This function that executes the custom event also has some variables that we can pass into this blueprint, and we'll look at those in a moment. So double clicking this takes us to the custom event within the first person character. So when we press E, we get this custom event which plays our entice sound, which is the whistle sound. And then there's some other stuff which we'll look at in a minute. But the important thing is here, which is that the PawnNoiseEmitter component of this blueprint is being told to make noise. Looking at that component, you can see that it only really has one setting, which is this noise lifetime. And this determines the point in time at which new sound events will overwrite any previous ones, even if they're not louder. So this creates an imitation of sounds naturally decaying in volume over time. So we press E when within our controller blueprint here, and that calls this custom event within the first person character, and then the first person character makes a noise. And this noise is at the first person character's location, and the first person character is identified as the noise maker. And we can also set the loudness of the noise as well. In this mode, it's simply set to 1. Then our baby griffin is listening out for that noise because it's had its sensing updates enabled here. And when it hears the noise, it triggers the movements. If we put a print string in here, we can see the instigator of that noise, which will be the first person character. So let's just check that again. So we walk into this collision box, and now the baby griffin's sensing has been enabled. So it's listening out for any noises that are made in the game. And we're going to press E, and that's going to trigger that custom event within the first person character to make a noise. And you can see it's identified that it is the first person character making that noise. Now, we've been talking about making noises and hearing noises, but the system doesn't make any real sounds at all. The whistle is just triggered independently. This system is a kind of fake way of achieving these goals without all the processing expense that would be needed to actually analyze the audio in real time. At the moment, we can see it's operating in quite a binary way. So if we go back to the baby griffin, and instead of looking at the instigator, we look at the volume of the sound, then we can see in the game that this is actually only ever reading out a volume of 1 because it's not taking into account distances and attenuations. It's just giving us whatever was set in the PawnNoiseEmitter as its loudness. So if we did want to base the reaction on the actual volume of the sound as it might be heard over distance, we're going to need to make some calculations. This is why we're sending in some extra variables to the first person character so that it knows what the listening actor is and whether we should apply our fake distance system. So let's just go back to the blueprint here, and now we're going to switch on this fake distance. Going back to the first person character, here we get the listening actor, and we're going to get the distance from the player to that listening actor and set this as the variable distance. Now we're going to get our entice sound here, and we're going to actually get its attenuation settings. Using the distance between the two characters and the attenuation settings, we can perform some maths that will give us a more realistic volume of the sound as heard by the baby griffin at a given distance from the player. So when our fake distance system is in operation, now the volume of the make noise will be determined by this volume scaler here. So now that print string should show us that the volume is changing according to our distance from the griffin. So there it's 0.047, now 0.015, now 0.31. So as the griffin's coming closer towards us, you can see that it's hearing our whistle at a louder volume. So now we could set things up so the listening character is only going to respond when the volume is over a given amount. So let's just finish with a quick reminder of how to set up a similar system yourself. You need an actor that is going to make the noise, so they need a PawnNoiseEmitter component, and then you need to trigger that component to make a noise, usually at the location of the actor itself. Then you need another actor to be listening out for that noise, and they need a pawn sensing component. So let's just find another actor. I'm just going to use this Audio Fairy 3 to test this out. Open that up. We'll add a pawn sensing component to this actor. And in this instance, we'll make sure that it's on by default, so enable sensing updates is true. We'll set some values for our hearing thresholds. and we'll create an event on here noise. Let's get a reference to this static mesh component here, and we'll just set relative scale so we can make this change size when it hears a noise. And we'll create a print string so we can see, just to check the instigator of that noise. So this has pawn sensing, the player character has a pawn noise emitter, and let's see if that works. So I'm going to trigger the player character to make a noise, and that should change the size of the blue fairy that we can see over there. Success. In this video, we've looked at how one actor can make noise that can be sensed by other actors through the pawn sensing component. Although this method is not necessarily that intuitive in terms of how sound actually propagates through space, it is a relatively cheap way, computationally speaking, to achieve the required effect.